Yesterday we did a review of the three types of regression models: linear regression, a quadratic regression, and an exponential regression. Today we're going to do something called residual plots, and a residual plot allows us to see if the model that we used, which was linear, exponential, or quadratic, is a good fit for the data in our table. And so that's what we're going to look at today. We're going to look at residual plots. And they're actually kind of fun. I know I say that about everything, but they really are kind of fun. So a residual plot is a graph that shows a difference between the actual data, the data that we put in when we're looking for a line of best fit, whether it's linear, quadratic, or exponential, and then using that equation to find the predicted data. So it's just the graph that shows the difference between what was actually in the data that we entered and then the data that we predicted. The independent variable and if you remember, the independent variable is our x variable, that's our x, is graphed on the horizontal axis, and the residual value, and we're going to figure out how to do that in just a minute, which is our actual minus predicted, is graphed on the vertical axis. And again, that's our y. So after we graph everything, if the residual data, or the residual plot, which is going to be our dots, if they're randomly scattered around the horizontal axis, then that means a linear model is our best fit. So that's this right here. Here's our x-axis. All our dots are randomly scattered all over the place. So that's a random pattern, which means a linear model is the model of best fit for our data. However, if we can see a pattern like this U shape or this inverted U, that means a linear model is not a best fit. So it's a nonlinear model we're working for. So if the residual pattern, or if the residual plot shows a pattern and does not appear to be random or scattered, then a non-linear model would most likely be a better fit. So how do we make this right here? How do we make a residual plot? Well, that's what we're going to take a look at now. So in this example, the data below shows the number of active woodpecker clusters in DeSoto National Forest. So we have from the year 1992 to 2000, and then we have our active clusters down here. So question A is asking us to enter the data into your calculator and find the line of best fit. And we're going to let X represent the number of years after 1992. So what that means is in our list 1, or our X, the years after 1992, this would be entered as a 0, 1993 would be entered as a 1, the 2, 3, 4, 5, 6, 7, and 8. And then in our L2, our Y values, the active clusters, would go in there. So use your calculator in list 1, 0 through 8, and then in list 2, the corresponding Y values, and find the equation for the line of best fit. Okay, you should have gotten on your calculator the equation for the line of best fit for this data set up here. Y equals 3.7x plus 19.867. Question B is also asking you for the correlation coefficient, which is R, so you had to make sure you turned your diagnostics on. And if you looked at your notes from yesterday or from the last couple of units, you know how to turn your diagnostics on. And the correlation coefficient for this set of data is 0.984. So describe the goodness of fit. Goodness of fit means positive, negative, and is it a strong positive, fairly strong positive, or a weak positive? And so this is very close to 1, so we're going to call this a strong positive correlation. Okay, so you should have this equation in Y1 of your calculator. Go ahead on your calculator and hit second in graph, which gives you the table of values for this equation. So that's going to give us our predicted active clusters. So the actual ones here, this is our actual data, are 22, but if you use your calculator and you go to second in table, or second in graph, using our equation for the line of best fit, we got 20. And we should expect a difference between there, because this is kind of taking all of that data, well, it is taking all of that data and averaging everything out so that we can use it to make predictions. But we're going to just compare the actual with our predicted. So at year 1992, there was 20, 93 is 24, 1994, 27, 31, 35, 38, 42, 46, and 49. And we do expect a difference between the predicted data and the actual data. They shouldn't be the same. Some of them might be the same, but they may not be the same. And we're going to use this data to make our residual plot. So to make our residual values, we're just going to subtract the actual value and the predicted value, and that's going to give us a residual. And we're going to do that on the next page. So to find the residual plots, we need to find the difference between what actually happened, and that was the data that we entered in the calculator to get our line of best fit, and what is predicted to happen. And that's from table number 3. So in 1992, the actual data for woodpecker clusters was 22. When we used our line of best fit, we got 20, so our residual is 2. For 1993, the actual was 24. The predicted using our equation for the line of best fit was 20. And so the difference, nope, it was 24. And so the difference between those two is 0. And then for 1994, the actual was 27 and the predicted was 27. So for a residual of 0. 1995, the actual was 27, the predicted was 31, for a residual of -4. 1996, the actual was 34, our predicted was 35. It gives us a residual of -1. 1997, actual was 40, predicted was 38, for a residual of 2. And then the rest, 1998, 99, and the year 2000. So this is the data. This residual right here is what we're going to be graphing in our new plot, our residual plot, to see, was our line of best fit a good, or was our equation for the line of best fit, the linear model, was that a good fit? So on the x-axis, which is this one right here, and we're only seeing part of the axis, that is going to be our years after 1992. And I'll show you how I split up my graph. When I do this, I just make a mark in the middle to get halves, then the middle of those middles to get quarters, and then the middles of those middles to get eighths. So this is 0, and then 1, 2, 3, 4, 5, 6, 7, 8. So this one right here is well, 0 would be 1992. This would be 1993, 1994, 95, 96, 97. You get the idea. So then on our y-axis is we are going to plot the residual value. That's this number right here. So again, to break it up, here's 0. I'm going to cut it in half and cut those halves in half so I can have an even scale on my y-axis. So 0, this is 1, 2, 3, and 4. And then -1, -2, -3, and -4. Okay, so we're going to plot the residual data, or make the residual plot. So the first one is 1992, and our residual is 2. So that would go right here, because 1992 minus 1992 is 0, and our residual is 2, so I'm going to make a dot right there. In 1993, that was 1 year after 1992, our residual was 0. In 1994, our residual was 0. In 1995, our residual was -4. 96, the residual was -1. 97, the residual was 2. 98, it was also 2. 1999, the residual was 0. And in the year 2000, the residual was 2 as well. So that's our residual plot. The green dots, or the residual plots, are what we got by taking our actual value and subtracting our predicted value, and it gives us a residual plot. So if we go back and look at our residual pattern, this pattern is scattered and random. There's no pattern to it. It's not U-shaped, or it's not an inverted U. So that scattered and random pattern means that the linear model is the best fit for our data. That's what we want to see for a linear model. We want to see, all these points scattered all over the place. So in question F, would you describe the residual plot as scattered and random? Yes, it is scattered and random. And what does that mean for our data? It means that a linear model is the best fit for this data. So what happens if it didn't look like this? Well, then we'd have to choose some other model. It would be quadratic, or it would be exponential. But residual plots are just another way to say, hey, look at which type of regression is best for my data, and in this case, a linear model is best for our data. Okay, now it's your turn to answer some questions. Multiple choice question 1. Look at the graph below. Decide what the line of best fit would be. So look at the pattern. Is it scattered and random, or does it have a specific shape? Does it have a pattern, and is it not random or scattered? Question number 2. Looking at question 1, how did you decide what the line of best fit would be? Describe the relationship or the pattern between the data. What does it look like? And again, we're looking at, is it scattered and random, or do you see a pattern? Make sure, multiple choice question number 1, answer your question in free response. Just make it short and concise on the Google form.